Hi math friends, today we're looking at angle relations in polygons. So before we start this, we have to know the total angle measure of each polygon. So before you start, count the number of sides. We're going to work with quadrilaterals and triangles today. A quadrilateral has a total angle measure of 360 degrees. So I count the sides, there's 4 sides on each of these. That means they each have 360 degrees of a total angle measure. With triangles, 3 sides, they each have a 180 degree angle measure. It's no matter how the triangle looks, as long as it has 3 sides. Same with quadrilaterals. All right, so we're going to use algebra to solve. So when we're using algebra to solve, we're going to look at a angle measure 1 plus angle measure 2 plus angle measure 3, so this would be for a triangle, would equal 180 degrees. We're usually given some of these values to work with so that we can find the other ones. If I'm looking at a quadrilateral, we're just going to write an A here, so angle 1, angle measure 1 plus angle measure 2 plus angle measure 3 plus angle measure 4. If I add all those up for a quadrilateral, they're always going to be 360 degrees. We'll look at some examples of these to shed some light on this and to start solving them. The important thing that we're going to be doing is using algebra, using equations like this to solve for unknowns. So let's look at this triangle. This says find the measure of the missing angle. So I have, this one is marked as 50, this one is marked as 45, and this one is marked as x. So I'm going to go ahead and write my equation for that. I'm going to add the angles together. 50 plus 45 plus x equals, and here's where we have to remember that for a triangle, there's 180 degrees total, no matter how that triangle is shaped. Okay? It could be a right triangle, it could be a triangle that's almost an isosceles triangle like this. It could be a scalene triangle. It doesn't matter how that is, the angle measures are always going to equal 180. So let's go ahead and solve. So I'm going to draw a line down the equal sign, and this should look similar to solving equations for unknowns. The difference here is we have a step here. 50 plus 45, we do that first, so we get 95, and then I rewrite the rest. Plus x equals 180. Remember to do inverses. So performing inverse operations here, we're adding 95, so do the opposite, minus 95. And remember, we have to do that on both sides of the equation. So over here, minus 95. So then I have x equals 85. So then my missing angle measure is 85 degrees. And you can check that too. We can do 50 plus 45 plus 85, and that will equal 180. That means that we did that correctly. Let's look at another couple examples here. Here's another triangle. Now notice this one is slanted. And remember that that doesn't matter. We're going to use the same type of equation. Add the angles together. 30 plus 60 plus y equals 180. And then remember to solve that, we'll draw a line down the equal sign. And then we need to combine like terms here. 30 plus 60, remember those are on the same side of the equal sign, so those go together. 180 is just 180. So inverse operation here, look where the variable is, subtract 90 on both sides. So when we do that, we have y equals 180 minus 90 is also 90. So actually that's a right angle there, it's 90 degrees. Final answer is 90 degrees. Again, you can add those up, 90 plus 30 plus 60, and that will equal 180 to check. All right, let's look at a couple quadrilaterals here. So remember, quadrilaterals, all these angles are going to combine or sum to equal 360. So when we're in our equation, we'll add all the angles. 70 plus 37 plus 40 plus, this is angle A, equals 360. All right, so we need to combine our like terms. So we'll add 70 plus 37 plus 40. So 70 and 37 is 107, plus 40 is 147. And on the other side, we still have just 360. We'll draw our line down the equal sign. And then we'll perform our inverse operations again too. So I have our variable over here, and we're adding 147, so subtract 147 on both sides of the equation. Remember, this line is really important to help us see that we're keeping things balanced here and doing these on both sides of the equation. So then we have A equals, we'll go ahead and subtract, and we get 213 degrees. All right, so remember we check that by adding up all the sides again. So we go 70 plus 37 plus 40 plus 213, and we do get 360. All right. The strange thing about that is if I look at this diagram, this looks like an acute angle, right? This looks like it's less than 90 degrees. This 70 degrees looks like it's more than 90 just by looking at it, and 40 doesn't look quite right either. We're going to see diagrams though where things are labeled, but they don't look quite right. So we have to be prepared for that. All right, one more. So we'll look at this quadrilateral, and we'll go ahead and add up our angles, 90 plus 90 plus 90 plus C. Since it's a quadrilateral, 4 sides, 360 degrees is the total angle measure. Add those all up, so 90 plus 90 is 180, plus 90 is 270. And then we'll go ahead and make sure that we perform inverse operations. So on both sides, look where the variable is. I'll have to subtract 270 from both sides. So then I have C equals 90. So our answer here would be 90 degrees. And again, we can go ahead and check by substituting that back in for C and doing 90 plus 90 plus 90 plus 90. We would get 360. And that actually makes a special type of quadrilateral here. That makes a rectangle. Not necessarily a square, but it makes a rectangle because all the angles are 90 degrees.